Now let's look at continuous numerical data. So what's going to be different about this continuous numerical data is that we're not going to have the clean bins like we had for discrete data. With the honeybee example, we had specific counts. But with continuous data, you often are going to have a lot of decimals, and you're going to have very unique values. Rarely will you have more than a few repeats. So if we were looking at this example, where we are looking at the enrollment in distance education courses by state from fall 2012, looking at each of the 50 states and the District of Columbia, what percentage of students at Title IV institutions were enrolled exclusively in distance education. So you notice here that we have lots of different values. We have these decimal values. We would not plot each individual value on that number line. So instead, what we're going to do is we're going to create intervals. You look for the smallest value and the largest value, if you're doing this by hand, to make sure that you can span the entire group. And so here, our smallest value is 1.6, and our largest value is 48.2. So if we started at 0 and counted by fives, then that would get us from 0 to 50. It would have potentially a few too many groups for this size data set, but for simplicity, we'll go ahead and split these by 5. Now, one thing when you're dealing with continuous data is these class intervals. You have to consider the boundaries very carefully. If you have a value that falls on the boundary, you need to make sure that it's clear which group it goes into. So here, we note this by saying 0 to less than 5 to indicate any value 4.99999 or smaller would go into that first class. But once you hit 5, you go to the second class. That second class, you start at 5 and every value up to 10, but once you hit 10, it goes to the next group. That way, there's no confusion as to which group that the number would go in, and also a number would only be counted in one of these intervals. So you would calculate the frequency of all of the values in each of these groups, and you could also calculate the relative frequency. Now you'll notice here, because of rounding, our total was 1.001. That is okay. That was not an arithmetic mistake. It was simply some rounding that happened throughout the problem. So now that we have this data set, we can look at what this would look like as a histogram. I've switched to the iPad so that I can show you how I go through this process by doing this frequency table and a histogram by hand. If you are doing this by hand, which will rarely happen because I highly recommend you use technology, but you would go through your list and just keep a tally. So I usually have to cross these out, otherwise I forget. So we have 16.0, 16.4, 48.2, 9.2, 6.3, 19.4, and I'm just keeping up with which interval each of these values falls under. So I skipped ahead so that you wouldn't have to see all of the counting that I was doing. But here we have the frequencies that you already saw from the table, and you could calculate the relative frequency here. There was a total of 51, and so you would take each of these numbers, divide by 51, and that's going to give you the relative frequencies. So you can calculate these on your own. It's just simple division. But now I want us to create a histogram. So when you're drawing a histogram, you have two axes. You have your horizontal and your vertical. Make sure you label these. So this is the percentage, and then the y-axis is going to be the frequency. And we need to hit from 0 to 21. So I'm going to count by fours. And then our percentages, we're going to use those class boundaries. So we have 0, 5, 10, 15, 20, 25, 30, 35. And now we just simply draw a bar that is the height. So from 0 to 5, I need to have a height of 2. From 5 to 10, I need to have a height of 21. From 10 to 15, it's a height of 12. 15 to 20, a height of 9. 20 to 25, height of 3. And if you're not using grid paper, it can be really hard to get these exact. Now from 30 to 35, there was 0. So we're just going to skip over that one. The only time you have a break in a histogram is when you have 0 values in that category. So here we have this histogram, and we're going to be talking about the shape here in a later section or a later video in this section. Now, how many class intervals should you use in histograms? It really varies. You want to have enough so that you can see the overall shape, but you don't want to have too many to where you have kind of this pancake. So if you have too few, you're going to have a skyscraper because you're going to have just a few really tall bars. And if you have too many, whoops, that's not how you spell many. If you have too many, you're going to have a pancake where it's just spread out too much. And so you want to find the number of intervals that produces an appropriate histogram. In your statistics, or sorry, in your StatCrunch lab, you'll be playing around with finding the ideal look for your histogram. I would say 8 to 12 is usually an appropriate number of intervals, but it really depends on your data set. You want to make sure that you have a good looking histogram.